Okay, in this video we're going to review the equimarginal principle. This was covered in Chapter 3 of the text, also in Chapter 5. This was in the first week's material. The equimarginal principle, or sometimes called constrained optimization, is used when a decision maker has multiple activities to choose among, as well as a constraint of some sort. The consumer, for example, has multiple commodities to choose. At the same time, he or she is limited by a budget constraint, and so in that case we would use the equimarginal principle. In general terms, the equimarginal principle says that to maximize total benefits subject to a constraint, we must choose the level of activity so that the marginal benefit per dollar spent is equal for all activities. Now, in this example, we want to look specifically at applying equimarginal to the consumer choice, to the consumer's problem. So we reword the equimarginal principle a little bit to apply it to the consumer problem. A consumer maximizes utility subject to a limited income by allocating income so that marginal utility per dollar spent on each good is the same for all goods purchased, and all income is spent. Don't forget that part of the rule. We don't maximize our utility until we've spent all of our income. So let's look at a problem. This might look familiar. Assume that an individual consumes two goods, X and Y. Total utility for each good is independent of the rate of consumption of the other goods, and we are given total utility for X and Y in our table. The price of good X is $5, the price of good Y is $10, and the consumer has $110 to spend on good X and Y. What combination of the two goods will the consumer choose? Let me enlarge this so that we'll have plenty of real estate to write on here. The first thing we want to do in applying the equimarginal principle is to convert total utility to marginal utility. And so marginal utility is just the change in total utility as we move up incrementally from one unit to the next. So if we assume that with 0 units of good X, utility would be 0, then the marginal utility of the first unit would be 50. We've gone from 0 up to 50. The marginal utility of the second unit of good X would be 45. That's 95 minus 50. And the marginal utility of the third unit would be 40, and so forth. We can just see the pattern. Be careful, sometimes these patterns change. 20 and 15. So this is the marginal utility for each incremental unit of good X. We do the same thing for good Y. The marginal utility of the first unit of good Y is 400, 350, 200, 150. That would be 120, 100, 80, and 50. So again, that's the marginal utility of good Y. Now, we don't make decisions based exclusively on marginal utility. We want to maximize total utility, and we do that by looking at which goods gives us the most bang per buck. You may have heard that expression. We want to spend our income in a way that maximizes our bang per dollar. So we need a measure of bang per buck. Well, that is marginal utility per dollar spent. Now, the price of good X is $5. So we're going to take marginal utility for each unit of good X and divide by 5. So 50 divided by 5 is, of course, 10. And I'm just going to run through this arithmetic rather quickly. 10, 9, 8, 7, 6, 5, 4, and 3. And the price of good Y is $10, so we're dividing marginal utilities by 10. That would be 40, 35, 20, 15, 12, 10, 8, and 5. Okay? So again, that's marginal utility per dollar spent for good Y. Now you may ask, why have we done this? Well, by computing marginal utility per dollar, it allows us to compare units. We can not only compare the value of the first unit of good X to the second unit of good X, but more importantly, we can compare the value of the first unit of good X to the first unit of good Y. Clearly, the first unit of good Y gives the individual more bang per buck than the first unit of good X. In fact, 4 times as much. 40 is 4 times as much as 10. So again, by computing marginal utility per dollar, we're able to compare units in terms of their value. Now, what's the Equi-Marginal principle say? Consumer maximizes utility by choosing a bundle of goods such that the marginal utility per dollar spent on each good is equal. So we want to look for values that are equal. Now notice there's a 10 here and a 10 here. Those marginal utility per dollar, those values are equal. That's 1 unit of good X, and it looks like 6 units of good Y. You might say, well, that's the solution. No, it's not. Remember the last part of our rule. We have to spend all of our income. With 1X and 6Y, we're only up to $65. We haven't spent our entire budget of $110. So that's not the solution. We keep looking. Here we have a match at 8 and 8. That is 3 units of good X. That would be $15. And 7 units of good Y. That would be $70. We're still not at our point of optimization. So we keep going and we find a match here at 6 units of good X, 8 units of good Y. 6 times 5 is 30. 8 times 10 is 80 for a total of $110. So there's the solution. The consumer will maximize utility by consuming 6 units of good X, 8 units of good Y. Very quickly, just another similar problem. Assume James purchases steak and chicken with an income of $60. The price of steak is $60. Price of chicken is $5. The following table shows the marginal utility James obtains from each additional pound of steak and chicken. So in this problem, we're already given marginal utilities. The totals have already been marginalized for us. So all we have to do is to compute marginal utility per dollar. Again, price of steak is $10, so 7,654, 3.2, 1.6. Price of chicken is 5, so marginal utility per dollar is 10, 8, 6, 4, 2, and 1. Now notice, again, the information we're given here is in terms of marginal utility. The first step has already been done for us. And from this point on, we follow the same rule. We look for a match. And it looks like we have a match here at 4 units of steak, 4 units of chicken. Just check that. Steak is $10. That's $40. Chicken is $5. That's another $20. So that gives us a $60. So we've satisfied our budget. So just be careful. Notice the 2 problems. One, you were given total utility. We had to marginalize that. In this problem, we were given the margin, and so we simply go to marginal utility per dollar. And again, we look for 2 points where marginal utility, with two quantities rather, where marginal utility per dollar is equal while at the same time satisfying our budget. So I hope this helps to explain and clear up some of the problems with Equi-Marginal as it relates to the consumer's problem.